Now, one thing that I noticed about these two denominators, it's really cool, is that they're prime. And so that, their common denominator is actually the product between them. Now, what I mean is, a very easy way to find a common denominator between two different denominators is to actually multiply them together. And I see that 5 times 3 actually produces 15. Now, using our infinite knowledge of ratios, we know that we could take 5 times 3 to get our 15, but what we do to the bottom, we actually have to do to the top. Okay, so let's take the top times 3. And the question here is, what could I take 3 times to get 15? It's this 5. Let's take 3 times 5. But what we do to the denom, we have to do to the numerator. Now, looking at this and knowing that we multiply fractions straight across, I know that 4 times 3 actually produces 12, and of course we have 15ths. That's what we wanted. Okay? Now our other fraction turns out to be not 12, but 2 times 5, 10 15ths. Now looking at this, we've made them both in the same size pieces. We have 15ths, but clearly one has more than the other. So we might say that 12 15ths is greater than 10 15ths by giving it the bigger end of this symbol. But the important thing here is that 4/5 is greater than 2/3. Moving on to number 8, it says, well, let's write a fraction in a decimal. Okay, two different forms of the same thing. Okay, but what we want is, we want that fraction to be bigger than this decimal. Well, nobody said we couldn't take the easy way out. I suggest we start with things that we're very good at. How about we just start with a fraction that we already know is a decimal? How about 1/2? So I say 1/2. And now we need to come up with a decimal. What I know is, this 1/2 needs to be bigger than my decimal. So let's think about what is 1/2 as a decimal. And I know that 1/2 as a decimal really is just 0.50 in disguise. So I would challenge you to think of several different decimals less than 1/2. I think there are many. And you could come up with as many as you like. Actually, the more odd you are about it, and I don't mean like 1, 3, 5, 7, 9, you might get some brownie points on this one, but I think you could probably come up with some very exotic decimals. Okay, so remember, we want to change our fractions into decimals so we can compare them easily. Okay, now looking at number 9, and actually numbers 9, 10, 11, what they're going to do is they're going to give you two numbers and ask you to compare them using less than or greater than. In the first example, actually on number 9, they give you two fractions. Now, this is a lot like what we saw on number 7, but here's the thing. When you want to compare two fractions, what would make them very easy to compare? Well, what would have to be true about both of them? You would want them to have a common denominator. So let's think up two fractions. Once again, just a quick review. How about some easy ones? Like 1/2 and 1/4. Now clearly, because we have common sense, I think that 1/2 would be bigger. But our ambition here is to make things the same before we compare them. Apples to apples. So I look at this and I say, well, let's find a common denominator between 2 and 4. And I know what some of you are thinking already. Well, 2 times 4 is 8. And you're absolutely right. If we turned both of these into 8, it would totally work for us. But let's start to think more along the lines of, we're lazy, or we utilize our time, and we want a least common denominator. So let's think about the multiples of each denominator and try and come up with the least common multiple. For example, the multiples of 2 are, come on, say it with me, 2, 4, 6, 8, 10, 12, 14, 16, and a 4, 4, 8, 12, 16. But you notice the smallest one they have in common is actually 4, which is really neat, which means I can turn 2 into 4 by taking it times 2, and of course, in turn taking the numerator times 2. But I also know that I don't have to change the 4. It's already 4. And just to rub it in, we could say, well, let's take it times 1, and take this times 1. Well, it's going to keep it the same anyways. It's the identity property of multiplying by 1. Okay, so we say, well, 1 times 2 is 2. 2 times 2 is 4. And now what we're doing is comparing the same fraction. We've got a new haircut. 2/4 to 1/4. And I challenge you to say, well, okay, which one has more fourths? And of course the answer here is 2/4. But the really neat thing is this. When you change them both into fractions or both into decimals, what you see start to happen is you start to come to grasp these things a little bit better, and you see how things compare easier. Now let's keep this in mind in the future. As we do more and more homework, you're going to see that we're going to be comparing fractions to percentages to decimals. Okay? And making them the same really helps. I hope this helps you with your homework. Good luck.